We have made it to the last learning target in our geometry standard, which was applying the Pythagorean theorem. Our last learning target, 4, is about I can use a right triangle and the Pythagorean theorem to find the distance between 2 points on a coordinate grid. So I wrote down 5 steps for you. So as you write this down, pause after each one and think about it. So our first step is to plot the 2 coordinate points on the grid if needed. So if I tell you to plot points 7, 3 and point 2, -5, you're going to plot those 2 points first. And then your next step is you're going to draw a straight line connecting those 2 points. So get out a ruler or something that's going to make a straight line and connect the 2 points you draw from line step 1. Next, draw a right triangle using a vertical and a horizontal line as their legs. So you're going to kind of connect them by going horizontally and by going vertically. Note, if this makes sense to you visually, that the line drawn in step 2 is the hypotenuse of the right triangle that you're trying to create. Step 4, determine the lengths of the legs and label the lengths on the right triangle. So you're going to count the space or the distance each of the leg lengths are, and you're going to record that on the actual right triangle. And the last and final step is to apply that Pythagorean theorem to that missing length. And normally that missing length that we're looking for is the hypotenuse. So we're going to go through 3 examples. The first example is, and the directions are, illustrate how you can use the Pythagorean theorem to find the distance of this line segment. So we can skip steps 1 and 2 because the coordinate points are already put on the grid for you, and that red line is connecting those 2 dots. So we're going to draw a vertical and a horizontal line that's going to create that right triangle. So we're going to draw a vertical one there and a horizontal one there. And I'm going to put the little symbol there to represent that's a right triangle. Now I'm going to erase that. Note that you can also draw it up. So I don't want you to think that you had to draw exactly the way. If you were looking at it and you're like, oh, that's how I would draw my vertical and horizontal line, you can do that too. So notice that's a 90-degree angle. I'll just leave that since it's on there. Next step, the 4th step, is to count how many spaces. So if you were to let's go with the horizontal line here on top. That's 1, 2, 3 spaces. So if you're thinking about traveling on a car, that's kind of like 3 blocks. 1, 2, 3 blocks. And then if we're looking at the vertical one, that's 1, 2, 3, 4. Or if you're traveling in the car, 1, 2, 3, 4. One of the biggest issues I see people call that is that is not a distance. You have to actually travel. So that's 1, 2, 3, and 4. Okay, so we can apply my Pythagorean theorem. A squared plus B squared equals the C squared. I know that my 2 leg lengths are my A and B. So I'm going to go 3 squared plus 4 squared equals the unknown square, which is the C, the hypotenuse we're looking for. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25 equals C squared. To get rid of the square, we're going to square root 25, and the square root of 25 is 5. So the length of C, or this length right here, is 5. Next example, illustrate how you can use the Pythagorean theorem to find the distance between point 36 and 62. So first we're going to have to put those points on the coordinate grid. So 6, 3, start at the origin. 1, 2, 3, and then up 3. 6, 1, 2, 3, 4, 5, and 6. So here's my first point. And then the point 6, 2. So I'm going to go over 1, 2, 3, 4, 5, 6, and up 2, 1, 2. And there's my second point. So those are my 2 points on the grid. I'm going to draw a line in between them. And then I'm going to go and step 3, remember, is to draw a vertical and a horizontal line from those 2 points. So vertically and then horizontally. Okay, so that creates my 90-degree angle. Again, you could have put it on the top half, so up here if you wanted to. But first of all, drew it on that way, so I'm going to continue to draw it that way. Count the space. 1, 2, 3, 4. So that vertical length is 4. Count my bottom leg. 1, 2, 3. So again, that's a 3, 4 triangle, and honestly, I just did the math again, but we can quickly show it. So it's 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. Then you take that square root of 25 equals c, and it's a nice rational number of 5. So this would be 5 units long. One leg is 3, one leg is 4, and then the hypotenuse is 5. Last example, we're going to use the Pythagorean theorem to find the distance between the points -5, -3, and the point -2, 2. So first we're going to go -5, 3. So 1, 2, 3, 4, 5. And then -3 would be 1, 2, 3, 3 down. And then -2, start my origin again, 1, 2. +2, that means we go up, 1, 2. So I'm looking for the point in between, or the distance that I'm creating right now between those 2 points. So I'm going to start with a vertical and horizontal. So I'll go vertical first, and then horizontal to make my right angle. I'll put the 90-degree symbol there so we can see it. And then we're going to count lengths. And since my 90-degree angle is up here, that means this side and this side are my legs. So I'm going to count 1, 2, 3. We can count it 1, 2, 3. And then 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5. So we're looking for C again, because that's the hypotenuse across from the right angle. So we're going to take 3 squared plus 5 squared, and that's going to equal my hypotenuse squared. So the area of this square would be 9. This area off the leg 5 would be 25, because 5 squared is 25. And we're going to add the sum of these two small squares, which would be 34. And then we're going to take the square root of 34 equals c. And this one I know is not a perfect square, so it's going to come out as a decimal. So we're going to round to the nearest tenth, and it comes out to be 5.8 when I put my calculator units.